We're starting the spring semester by reviewing just for a day or two matrices. We'll march on probably tomorrow or the next day into a totally new topic that we've not seen before. But for now, this very difficult topic of matrices uh, is what we're looking at. So in question one, we're going to use something called a parallel array. That's a new term for us. And I try to explain that in class a little bit today. A parallel array is just an array that works with another array or another matrix. It keeps track of something. For example, we're going to have an array that has only two positions that keeps track of the average of the two columns in this scores matrix. If we were keeping track of the average of each row, then we'd have to have a size 3 and call it maybe row averages equals new double 3. Okay, so parallel array, don't be afraid that it's a very easy concept, but it's a word or a term that we've not used yet. So let's see what I've got for you here. Got the code there I want you to use. The AP exam puts constants in section 2 every year, so you'll see constants. So what I'll do first is just loop through the first column and get the sum of the first column. In fact, I'll make a note here. Loop, I'll do shorthand too, through the first column, and then I'll loop through the second column. Okay? The first column is column 0, and the second column is column 1. Okay? And I'll find the sum of each column. The sum variable I'll use is that call sum up there, which is already set to 0. Now, before I go from the first column to the second column, I'm going to make sure I reset column sum back to 0, or else all the values, the sum of the values in the first column will go into the sum of the second column. We don't want that. So for int I guess we can go through, let's see, for int I equals 0, I less than the num rows. No, yeah, num rows. We use that constant. I want you to use the constants up there. Don't need to, but the AP exam will, so it's a good habit to do it. And I guess we don't need braces, do we? Do we? I don't think so. Let's see. Call sum plus equals scores of I, and we're staying just in the first column. Okay, and after that loop is over, then we'll put the average into call averages our array. So call averages of 0 is call sum divided by what, num rows? Just on like on the final exam, and just like the AP exam every year, I'm testing you on casting here. You got to cast something to get the double. So we'll just mirror that down here in the second loop. Let's see. I know I'm forgetting something. Do you know I'm forgetting? Change that to 1. Change that to 1. What did I forget to do? I told you. A common mistake. I'll put it in the middle where it's obvious. You got to set call sum back to 0. Okay, you can go too fast on this and not quite get that right. So let's see. Looking good? Let's see if this compiles. No problem. Let's run it. Let's see. The average of the first column, 100, 200, 100. That's 400 over 3, which is 133 if I did it right. Let's see. Yep. And the second column is 100, no, 200, 300, and 100. That's 600 over 3, which is 200. So it looks good. Our second little tester, second little assignment, has us go through a matrix and look for the smallest even number. A very typical algorithm you've done many times before with arrays or other kinds of data, but now it's with a matrix, and you've done this before too. So we make smallest something very, very big to ensure that the first thing we check becomes the smallest. And you could have made smallest equal to maybe numbers of 0, 0, right? Top left, the very first one you check, you could have said int smallest equals numbers of 0, 0. What the AP exam will do typically is integer.max value to make it the biggest thing possible. That's the biggest number in the int range, somewhere around positive 2 billion. So let's go get this done. This is a really short one. I'll use R for row this time. Name of the matrix is numbers. Number of rows is numbers.length. I'll use braces to make it look nice. If you read that handout I gave you for your reading assignment, they didn't do numbers of R dot length to find number of columns. They did numbers of 0. And since the College Board wrote that, that's what to look for on the AP exam. Either way works fine, R or 0, because it's guaranteed to be a matrix with the same number of columns as rows. It won't be what our book calls a jagged matrix. So dot length. Now, well, we can make our if a little shorter if we say int num equals numbers of R C, and then just say if num is even, and if num is less than smallest, then we found a new smallest even number. See, if I hadn't done this line here, int num equals numbers of RC, I would have had to type that in here and over here, and I don't like typing those square brackets any more than I have to. And that should do it. Test it in a second. And compile. Looks good. So the smallest even number is what we want to display. And you see the smallest number is 1, and the next smallest number is 3. But they aren't even numbers. We want the smallest even number, which hopefully is indeed 22. And where is she? There she is right there, 22. And that is the smallest even number. Looks good. In our third matrices assignment, in tester 3, we're given a matrix that is passed to a method called biggest row. And that matrix parameter is called numbers. So we have to look inside numbers and find the row with the largest sum. So you don't return the sum of the row, you return the row number. So for example, if it's this mat here, a matrix which becomes numbers, the first row, which is row 0, has a sum of what? 20. The second one's got a sum of, I think, 2. Third one's got a sum of 44. And the next one, last one's got a sum of 16. So it's that third row with the biggest sum, 44, but you don't return 44, you return the row number, which is 2, right? 0, 1, and 2. So that's what's funny here. You're not returning the sum, you're returning the row number with the biggest sum. So it's our usual nested loop. I'll use R for row. Again, the AP exam does the number of columns with numbers of 0 dot length. We saw that on our reading assignment. So now what do you want to do? You want to add up the values in this row. Well, what do you add it to? We need another variable, don't we? Now, usually I say don't put a variable, don't initialize, not initialize, but don't declare a variable inside a loop. But this time it makes a little bit of sense to. Well, let's declare it outside the loop anyway. Let's make a variable called row sum, which is the sum of the values in our current row. And we'll say row sum plus equals what numbers of our C. And then we want to see, once we add up all those values in that row, each column has a different value within that row. We want to see if that row sum is bigger than the big row sum, our biggest one so far. If row sum bigger than big row sum, of course, big row sum equals row sum, but that's not it. We don't want to keep track just of the sum. We want to keep track of the biggest row. That's what the variable big row is for. So we say big row equals our current row R. And then after you check that row, what do you got to do? You got to set row sum back to 0, or else after row 0, we have, what, 15, 20 inside row sum, and then row 1, or the second row, becomes not 0 plus 1, but 20 plus 1, and that 20 gets added on. So we don't want that. So we have to set row sum back to 0 someplace. We can do it here. Row sum equals 0. That'll work fine. Or we can do it at the top of the outside loop. And that's why this might be a good candidate to actually declare a variable inside the loops. Because now if we do int there, we don't need this up here. So I don't know, maybe your professor in college might not like that. I don't see a big problem with it, even though I don't like usually declaring variables inside loops or inside ifs. Do I have my return statement? There it is, return big row. So let's make sure it returns row 2 like we said, and we can march on the tester 4. Let's see. Display that returns a 2, and so row number 2 is a big one, not row 0, not row 1, but row 2 is the biggest one, so we're good.